Hello valued viewers, I hope you're doing very well. It's Boxing Day, 26th of December 2020. Alison has allowed me to do some mechanics on the car. This is our daily car. It's a Renault Clio 182, nicknamed Eves. Today we've got to do the timing belt change, an auxiliary belt change, an inlet cam dephaser change, and a water pump change. This is essentially standard every 5 or so years, just stuff that needs to be done. As well as that, it's a good chance for us to fix a problem we've got. You can see it's all gunky, it's oil, engine oil that's leaked out. I've made an error probably at some point in working on this engine, and I've messed one of the seals up. It's a normal thing for a non-professional mechanic to do, and oil has been leaking out, so it's a good chance for us to really try and get to grips and solve that problem. It'd be really nice to get that done, because otherwise it's a decent car. I hope some of you might enjoy watching. We can talk about it as we go. Things to point out: this is the Renault F4R cast iron engine, pretty standard for Renaults at the time. 2004 car this is. Otherwise in pretty decent condition. 78,000 miles. Pretty standard timing belt, teeth timing belt tensioner. Then this is what we call a non-standard car for me. This isn't the usual kind of thing I buy. I came about it due to, well, weird reason, just because of a neighbour basically. Usually I don't like timing belts. I still don't like timing belts. I like timing chains. Historically, otherwise, I always bought cars with timing chains. Much superior, I think. Auxiliary belt with an interesting. Now, the interesting thing about Renaults I find working on these is they are very, like or hate French cars. Renault are very unique. They've always gone their own way, a bit like Dassault did. It must be a French thing. I'm very stubborn, refuse to follow anyone else. They do things very differently to other people, as we'll discover. Anyway, tensioner unit, pretty standard for Renault. Toothed auxiliary belt. Inlet cam dephaser. I'm not 100% sure, but this is just general knowledge. Obviously, you have a dephaser on the inlet cam, known as VVC, variable valve control. It allows, at certain RPM regimes, the inlet cam to slip a few degrees clockwise or anti-clockwise to change your valve timing, to essentially not change it to a different cam profile, because that's not what it does. It just changes the timing and give you a little extra, more or less torque in certain regimes. I've actually heard that this is actually what we call a dephaser, and so this actually reduces power, which is interesting. I don't know how true that is. You guys let me know what you think on the F4R. Apparently it's actually to stop too much power at the top end, and it's all emission control and bollocks like that. If that's true, then it'd be really tempting to just replace this with a solid pulley, or block this to stop it dephasing. We can get more power out of it that way. However, it might not be that simple. You may need ECU changes and fueling changes and stuff like that. So for the time being, let's just get on with it. Also, great opportunity. I've never taken a dephaser apart before. I think this is an oil pressure centrifugal dephaser, I think. And the great thing about that is we can, because we're removing the old one, we can just take it apart and explore, which I think would be great fun. It's just going to be nuts and bolts at the end of the day, although they do look like interesting nuts. So I think oil is going to come through the inlet camshaft under, presumably under an amount of pressure. It's going to go in through here. These are just colours, obviously. It's going to in through here, and then because this is spinning, when it gets to a certain rate of certain RPM, there's going to be enough centrifugal pressure for the oil in this bowser here to do something. What that thing is, I don't know, but if we look, we can see a small piston there. So presumably, and this is a guess, but presumably at some point, some pressure, that oil centrifugal is going to push on that thing and do something. Allow this wheel to slip, or stop this wheel slipping around the outside, something like that, right? So I think it'll be really interesting if we ever play with that. So that's that. Water pump, not much to say, standard water pump. Again, they just wear out, get rusty, get crappy, get inefficient, so it's good to do change them. It barely costs anything. One good thing about Renaults, if you're ever thinking of buying one, is, they're good cars, just no bone about it, but parts are so cheap, they basically pay you to drive them. Full rebuild, I haven't done this, but full rebuild for the head, say you smashed the head up, and you need to redo all the valves, your valve seats, your holders, everything that you could do, all sorts of bits, gaskets, everything, head gaskets, 10 other gaskets, everything, valves, everything for less than £200 delivered. I mean, next thing is, if you're still with me, we're going to strip it down as far as we think we need to. Now, the interesting thing about this is these become DIY cars. By that is garages won't touch them. They built the car, which is a very small, just a little tiny little hatchback with a big engine in it, an F4R, which is quite a big engine, and it doesn't fit. Is the interesting thing. The little space we've got there to work with, less than an inch, doesn't fit. So garages refuse to work on them. You can't. This car came to me because the alternator went. Yeah, alternator is a perfectly normal thing to go, but to change the alternator, you need to take the engine out. That's how ridiculous it is, because nothing fits. That's the official thing. That's what a garage has to say. Now, if you're a DIYer, you can do it perfectly fine without taking the engine out. I've done it, obviously. That's how I got it cheap. Again, timing belt. A garage is going to demand to take the engine out, and that writes the car off. You know, it costs. How much does it cost for a garage to take an engine out? And a lot of money. Which is why they become DIY classics, like we've got here. Obviously, I'm going to do it without taking the engine out. Anyway, I'll stop yapping. I'll report down back when she's stripped. Welcome back. So, stripped all the front off, removed the offside engine mount, so it's no longer hooked up there, and we've got a jack underneath holding that up. Emptied the water system out. Obviously, that's got to be done. Interestingly, I found this thumping great lump of iron on the offside corner. No idea what it's for. It just appears to be a massive weight. It weighs about 5 or 6 kilos. So I just removed it. I don't think it needs to be there. Inspection. Nothing. Haven't really discovered anything important at the moment. Giving it a little bit of a clean up. Next, I guess we need to take this cam cover off. Just mess around with these electrics, but it can't be that difficult. And get the auxiliary belt off. I don't see any reason why that should be kept in place now. And report back, stand by. Welcome back, Village viewers. We've stripped it all the way down, or as far as we need to go. So where are we? It was really difficult to ascertain where the leak was. I don't think it was sealed between the cam cover and the cylinder head, but just in case, I've high temperature sealant around there, those joints, just to make doubly sure. So if there is any kind of leaks in there, hopefully that will stop that. The most likely thing, and this seal seems good, this is the exhaust cam, this seal seems good, there was no obvious leakage here. My prime suspect is this guy here, which is almost certainly going to be at the top here rather than down there, because just reasons, it's just much more likely. So my suspect is the inlet cam there, so you have a phaser wheel that goes in there as you saw earlier, and the seal was a rubber seal. It was ever so slightly damaged. You know, which it didn't look damaged enough to leak, but maybe it was. B, it's, from looks on the internet, this seems to be the most likely cause that other people have been finding, for whatever reason. So I've ordered a new seal to come here. I'll probably just reuse that one because it just doesn't look problematic. So I've ordered a new seal, which I'm just waiting for to come here, and then we'll fit that before we go much further. So we're now at the just about to reassemble. Basically, I've obviously stripped everything all the way down there, removed both belts and whatnot. Haven't seen any other problems. Pinned, hopefully I've got this right, I've pinned both cams now with this. You need a lot of special Renault tools. So I've got a whole box of Renault tools in the boot. So you either need to weld your own tools up, which is a pain in the butt, or you get the special Renault tools. So I've kind of gone halfway. Just things like that. But because it's so awkward to get to this engine, you need to weld little things up to make that and that. I've done another one, I can't see it, it's here somewhere. And modified brackets like this. This is for a different Renault, but just modify it slightly and you can get it to work for this, stuff like that. So that's what we're doing with that. Now before I do reassembly, I really need to fit the water pump. The problem with the water pump is because Renault, it turns out, are just incredibly awkward. You won't believe how much swearing has happened just because everything is weird. They use these all over the engine, inverse Torx, so you need female Torx sockets to get on the end of them, which I don't have, so I'm probably just going to skip the water pump unless I can find a more maker tool to undo them, because I've delayed buying more and more weird tools than to do this. And I'm getting pretty fed up now. Eventually we need to actually go somewhere with the car, so I may skip the water pump, we'll see how it goes. That's that. I've got to clean everything else up now before we start reassembly. Stand by. Okay, had a bit of a problem. Had to end up removing the coolant system because this is the TDC pin down here, so that locks the crank in position at top dead centre, but I just couldn't get to it. Everything's so cramped in this engine bay, so we just took that off. So that's now locked. The crank's locked in TDC with piston 1. The cams are now locked in position. So now we're going to have a clean up down here and start getting the various pulleys and things back on, and hopefully we can try and get the belt on. Stand by. Welcome back, valued viewers. It's a different day and we've pretty much finished setting the timing, so still locked on that side there, still with our TDC pin in there. I can see it somewhere down there. We've been setting the timing, basically it's called. So we've refitted everything. Everything is, got 3 new pulleys, 1 new tensioner, 1 new VVC dephaser and crown wheel, and we just use the old exhaust guy here because that just gets used forever. New nuts, new bolts, everything like that is new. And what you do is you, if you have never done, and new bolt down there for the acoustic dampener and the crank sprocket. So what we do is we fit everything on, roughly align, then we go through an alignment process to align him, and him down there to the cam, because these are viscous, bearing in mind they're not actually linked to the cams in any way other than the pressure you put on the bolts. It's a really weird system I've never worked with before. And that guy down there is tightened, if you like, to the crank in a certain way. And then you use this guy here as the clever bit, is the tensioner. And what we do at that point is with the whole engine internals locked in place, we rotate him, and basically the whole timing set around and round and round and round, and it slips on the cam, it slips on the crank obviously, which are locked in position. And then every rotation I'm going to analyse and change the tension of the belt using this guy here, using I don't know, I've never taken one apart, some sort of, I don't know, some sort of rotational spring mechanism. And then you rotate the whole thing around, retention, rotate the whole thing around, retention, rotate the whole thing around, retention. Takes about half an hour or so until we're happy that everything is perfectly aligned. And each time I'm going to tighten these bolts a little bit more to push everything onto the engine, if you like, until we're there. It takes about 10 turns in total. We're at the point now we've got everything in, we're now locked in, and all the bolts are tightened, and each one of these bolts has got to be torqued properly, and then you torque it with a torque wrench. This goes down there, and then you have to rotate it through a certain angle. So that one's 86 degrees, that one's 115 degrees, that one's 135 degrees, and so on. Never understood that, why you torque a bolt and then angularly torque it. If anyone out there knows that, it's just beyond my level of mechanical understanding, but I always found that really interesting. So everything's on, it's torqued, it's rotationally torqued. That essentially, theoretically, is the timing set and done. So now we've just got to start unlocking the engine, taking the various things off, putting all your various covers back on, and we're going to check the timing again after that. Stand by. Okay, valid viewers, welcome back. The engine's all back together, electronics are back on. Don't have a water system on, but I don't need that. I just need to test it first to make sure everything works. Auxiliary belt is on and tensioned. You can see this guy here, called an automatic tensioner. Quite a clever design, I think. Because it means you don't have to check the tension of the belt ever. And that's going to go for another 5 years or so. Everything's the engine's now supporting itself. It's on its own mounts, where it was I had to take it off the mounts to move it previously. So battery's in, battery's charged. Let's give it a go, I guess. This is always the worrying bit, because if I've got that timing wrong, and the engine will literally smash itself to pieces, which I've done before. So stand by. Come on, baby. And relax. Ta-da. Well, that's just saved me £1,800 because this is an engine out job for a garage. Right, another job done. I'll get on with whatever I need to do next. Thanks for sticking with me and see you later.